How many of you are doing training? Okay, fewer. How many of you need GPUs? How many of you don't know you need GPUs? Always get a couple. Anyways, my name is Kyle Bell from Tensoroid, VP of AI. I want to give a brief introduction to what our company has been doing. We were founded about 2 years ago into a very interesting landscape that was kind of dominated by a singular company, won't name who. That being said, we thought that we really needed there had to be an alternative, right? So we really wanted to be able to democratize compute and AI infrastructure and kind of give people an alternative. That being said, at the time, there was only really one company that made sense to partner with to do this, and that was AMD. We leverage AMD Instinct GPUs exclusively. We're an AMD-only cloud, but that allows us to really dive deep, focus on a single platform, and really squeeze all the performance that our customers require. We were actually one of the original MI300 launch partners. I believe we were first to rack. First to revenue on MI300 as well. So this is mid last year. Over the course of this year, we were the first to deploy AMD direct liquid cooling with a very large MI325 cluster. And then very recently, we're also first to deploy the MI355 with the new AI Polaris NICs in production. So we do have customers already using this. And then going out to 2026, we hope to scale immensely, and then hopefully keep our good track record with the MI455X. That being said, let's get to building some agents. I want to introduce Monty from AMD.
Hello. Thank you, Kyle. Before I get started, how many of you guys are part of the startup ecosystem or have your startup or here on the startup program? Great. So this is actually my second time being at Web Summit. I think the first time I was here was about 1.5 years ago. I was part of a startup that probably didn't last too long, so if you need any tips on what not to do, feel free to reach out. On the other hand, I'm very happy to have the Tensoroid team here. If you need tips to be successful, talk to those guys because they've been doing amazing. So for today, we're going to be using AMD GPUs to build an AI agent together. So it is a hands-on session. So if you have your laptop or any sort of device that you can follow me, please take it out and connect to Wi-Fi. I'll go through some slides and then we'll switch to the Jupyter Notebook, which you guys have access to once I show the URL. Okay. To start, I'm going to show a video about what is an AI agent, and an example of that I just tried using AMD GPUs. Before that, how many of you guys have ever used AMD GPU for your AI development? I see a lot of potential here. That's great. Okay, so AI agents. The example I'm showing here is one of the open source software that I used. As part of my job, I have to check to see what open source software is out there that I can try with AMD GPU and make sure they work. If they don't work or if there's any problem, we try to fix it and reach out to the owners. So this one in particular was very interesting for me because it does the web browsing for you. So all I had to do is just prompt it, hey, I want to make chili for dinner tonight. Can you find the ingredients for me and put it in my basket? So you can see in this scenario, the agent actually autonomously have to think and reason that, hey, if this guy needs to make chili, I need to figure out a recipe for it. From the recipe, I can extract the ingredients and then put that in the shopping cart. So this example kind of demonstrates that how that's autonomously done, and you can see it puts everything in my shopping cart. And the cool thing is, for AI agents, almost anything I've seen out there is hardware agnostic. So as long as you run your LLM or vLLM on any GPU, it should work. And today we're going to show you how to do that with AMD. switching back to my slides here. There's this one right here. So at this point, I would like you guys to actually access this URL that I have here. So typing that on your browser should give you access to a Jupyter notebook. That will give you a dedicated access to an MI300 GPU. Right? We're going to be using that in a second to run an LLM that is open source to use as your brain for your AI agents. So I'm going to leave this on, and if you want to take a photo of this and have it on your phone if I move too fast so that you can have access to it. This will be up for about an hour and a half, and then we're going to take it down, but for now you can access it to get access to the MI300 GPU. I do have my colleagues there, Aman from AMD as well, that can help you if you have any problems. Kyle also was kind enough to do this with me before this, so he can also help you with it, so please put your hands up if you have a problem. We're going to start with something to do blindly because we're going to start loading the model together right now, and that will take a bit of time, so I want to save time given that we only have 45 minutes. So I'm going to switch to the browser with that URL that is already loaded. I'll explain what I did now in a few minutes. So you just bear with me, just follow what I do blindly, and we'll go over it in a bit. So if you scroll down to this part, it has a little picture of how to start a terminal on your Jupyter notebook. And there's a little command here. So I want you all to copy this command entirely with me. And then you should have a plus button right here, one of those. And you should have a terminal icon that you can click and get here. And you just paste that command and press enter. So I did this right before this we start here, so you guys maybe saw it. But at the end of it, you should get 3 info lines like this. It will take a few minutes. It's gonna download the model if it's not available in your GPU node, and it will load it to the GPU, and then it will be ready for you to serve. We'll get to the details of it in a bit. Just trust me for now. Run it. If you have any problem, please put your hands up. One of the guys will help you with it. Okay. So I'll just do some introduction to AI agents, and then we'll go back to the notebook and we'll complete the whole thing together. So AI agents, what is the distinction between LLM and agents? When you think of LLM, you can think of it as a really smart book. So you can ask it any question, and it will try to use the training data that it had to answer the question. But if you ask it some real-time questions such as what is the date today, and you run that model locally with no tool access, it'll actually fail to answer that, right? You're gonna get some answers such as, hey, I don't have access to any real-time tools, so therefore I don't know, or it'll just make up a date for you and say, hey, this is a date. So we can solve that problem if you turn that LLM to an AI agent. So basically, in agentic frameworks, you can add that LLM as a brain, and you can add tools to it, and that same model suddenly can answer those questions for you. So if you ask, what's the date today, it will check to see if it has access to any tools, and if it has a tool at its disposal, it will respond to you that, hey, the date is, whatever the date is that day you ask it. How is that done is through a paradigm that normally called as React paradigm. This happens through your LLM starts to reason first based on your prompt. It will act on it, so it calls the tools to see if it can respond to your prompt. And it will check to see if the response is correct. And if it's all good, then it will give you the final answer. This is a loop, so if it fails to do so, it will keep doing it until you get the final answer. And this is usually built into the agentic frameworks. So to build an AI agent, you technically need 3 components. I forgot to mention, I actually brought some giveaways from AMD here, so I'm gonna be like explaining stuff and maybe ask questions later, and just the ones who get it right can win a prize. If you have enough time, there's a little challenge at the end of this workshop. So the first 3 who finish it also get a little giveaway from AMD. Okay, so going over the three components that you need. One of them would be some sort of framework. You can build that from scratch if you want, or you can use one of the pre-made ones. That is the whole point of this framework is to actually make it super easy for you to connect your LLM to it, and then add your tools, and it will go through that React paradigm that is described. Today we're going to be using PydanticAI, and the reason I use that is because it's super simple to use. You don't have to use it for your own work. You can use any of the open source ones or paid ones. And the cool thing is, as long as you have your LLM running on any GPU, you should use this. So AMD is great. We're going to show you how to do that with AMD. And in case if you want to use any other ones, I have highlighted a few of them up here because based on my experience, they're pretty good to use. So LangGraph, OpenAI, Agentic SDK, CrewAI are some of the notable ones that I wanted to mention. The other thing you need is tools, right? So when it comes to tools, you can actually write that yourself as a Python function, and you can expose that as a tool to your LLM, and that will do the job. But the problem with that is a lot of the tools that you want to write, somebody else probably done it before, or it's some sort of enterprise that you need some sort of authentication. So that's when MCP comes really handy. So it's super simple to hook up the MCP server to an agentic framework. And today we're going to show how easy that is through a couple of examples. So the cool thing with MCP is actually you can have 10, 20, no matter how many functions you have, packed as one package and expose all of that through one API call. The last component you need is your LLM. How you get that LLM running is you can choose again based on the different methods to do so. vLLM is one of them that we're going to use today. There's SGLang, or there's PyTorch or Hugging Face Transformer. So you have a lot of options to use. vLLM, one of the best ones to use in my opinion, is super simple, and you'll see why in a few seconds. Okay. I think at this point I want to switch back to the notebook. We'll get back to the challenge if you have time. But let's get to the notebook and see if we can finish this workshop together in the next 20 minutes or so. So do you guys have all the notebook running and you got the 3 lines that I have? You guys all good? Okay. That is great. So from here on, we're going to be running these Jupyter Notebook cells together. So the way you run them, if you've never done it before, you can click on the cell, press the play button right here, or shift enter to do the job. And I'll explain one by one what we're doing. Before doing that, I just want to quickly cover what we just did. So as I mentioned, running these models on AMD GPU is super simple. So basically all you have to do with vLLM, which right now we've installed vLLM for you guys, is vLLM serve model name, and that's it. The rest of them are optional, right? So I can go through what I've put as the options here. But you can see the vLLM serve, the model comes directly from Hugging Face. So I just copy pasted this from here, right? So you can go on Hugging Face, choose the model you want to run, and just copy the name, and that's it. The parameters you see here is basically optional. Some of them are, you can guess what they are. For example, I want to choose the model serving name to be a specific name. That is the first one. I put an API key for myself, the port number that I want to be serving the model from. And the last, the next 2 are for tool calling. So each model has its own tool call parser. So for Qwen, we use Hermes. You can look up the tool call parser based on the model from the model card. And that's it. Basically, that's all you need to do to run the model. And now you have that model ready for you to run. The cool thing is that will give you OpenAI compatible endpoints. So here, that is the format you're going to get. Since you're running that locally, it's going to be localhost, port number you pick, and v1 from OpenAI protocol. This is basically setting up your base URL. So let's run that together. And you should get a green with a config set, just the way I have it here. Next, we're just going to hit that endpoint and make sure we can actually get a response from the server to make sure the server is running correctly. All right. So you should all have something like this that says, hey, point 330D is running, and that is ready for you to be served. So far all we did is just make sure the model is running and you can get a response from the server. Next, we're going to dive into how to build the agent together. So starting with the prereqs, which is the libraries you need. PydanticAI is the main one. OpenAI is also, because we're using OpenAI compatible endpoints, therefore we need those sort of libraries to be added to our environment here. So that should take a few seconds. You should get this. And next, you basically want to set up our agent. To do so, PydanticAI has a specific way of saying, hey, if you want to basically connect to your OpenAI compatible agent, make sure you set the specific library with these parameters. That's an example for you guys to take a look at. I'm not going to explain all the details here, but you should be able to just run this. That will set your endpoint. Please ignore this deprecation warning. We'll update that later. But it should be ready for you to use. And finally, this is how simple you can actually start an agent with PydanticAI. It's just a constructor for agent. You connect your model, run it, and that's it. So the one little thing I have here is a helper function, because I want to just be a prompt and get a response from my agent. So that's all I'm doing here, making a helper function called onAsync. Now we'll set it. And then now let's try running the model. So what is a capital of France is a question I'm asking. You should get a response like this. Does it work for you guys? All right. So a question for you guys. If I ask it, what is the date today? What should you get? Put your hands up, because I'm going to give you a prize away. You want first?
It won't give you the date, because the maximum date he knows is when it was trained.
Exactly. I haven't connected any tools to it. So we're going to try that next and see if you just literally call what's the date today, you will get basically a response, hey, I don't have access to real-time data, and that's why I don't know. You're free to use either pick up a water bottle or one of those Lego kits that is an AMD GPU. So Carl is gonna.
The Lego.
Lego.
Thank you very much.
Okay. So you saw that exactly what the behavior we described is happening right now, and you can get the date. A really simple way to fix that problem is you have a one-liner Python function. We're using PydanticAI's tool decorator here, and all we have to do is just set that function, call the decorator, and that's it. So let's try it. So this basically creates a tool called getCurrentDate. Now, if I just go here, add this tools parameter to the agent that we just created. So it's using the same model. We just added the tools to it. And I'm adding a system prompt, but this is a trick question, just a second question. If I don't add the system prompt that says get current, so you have access to this tool, is this gonna work or not? Are we gonna get the current date?
I think not yet. We have to give some instructions. What is the purpose of this MCP server and how to use it?
Not quite.
I think it won't work. It's something to say hi or something like that.
And do you know why it should work?
Because I don't know why, but if we want to set system prompt, for example, for legal chatbot, we have to set some prompt related legal things or
Yeah.
agile. For example, I am creating on my company agile and legal chatbot. I am setting related things about that, but when I didn't set anything, they are always answering any question.
Yeah, so you're correct.
Yes.
But the reasoning was,
Yeah, I know.
okay.
I mean, all the prompts are concatenated and the roles are concatenated, so you can provide either system prompt or user prompt. It's just for convenience to divide the roles, because in user prompt we provide what is changing, and in system prompt what is like static and we want to keep for all other requests, basically.
Okay. But how does it know if it has access to the tools? Do you know?
Those models were fine-tuned to using tools, so they have this capability, and basically they will involve
Okay, the model
according to the
has
signature
access
of
to
the
it.
functions.
So that's correct. So you can pick one of those with a few. Sweet. Okay, so yeah, in short, the reason I'm putting the system prompt is not because the model that they is not going to work without it. It's mostly to make sure that agent actually calls this tool. The reason we're using the agentic framework is when you have tool calling enabled for your model, actually, anytime I use this decorator that we did here for this section of the code, what it actually happens behind the scenes that you guys don't see is PydanticAI is compiling a list of a duck string that, hey, this is the arguments for this function, this is the purpose of this function, and you can have access to it. And it's passed to every single prompt you say. It's hidden, but if you put tracing, you can see it. It's actually passed back to the LLM, and the LLM actually knows that it has access to this function. However, if you use small models, say like less than 1 billion, that becomes a bit tricky. So those models are not the best, maybe, depending on the model. I call in. So for me, usually in the agentic frameworks, when I want to use them, I actually specifically say, hey, you have access to this, so call it when you need it, right? But technically you don't. So later you can try it. You can actually prompt this as what are the tools that you have access to without the system prompt, and it should tell you. Right, let's run this. So we're expecting now that we get, hey, today's date is November 13th, 2025, so it should be correct. And now the same model that didn't have access to the real-time data, it does. Okay, so now is where MCP comes to play, right? We talked about it briefly, but there's a lot of functions and APIs out there that you want to actually connect to your AI agent. And if you were to write the functions for this, it would be a whole project, right? So to save you guys time, a lot of people are actually pushing all their MCP servers. Recently, I saw actually ChatGPT. Even there, you can actually add MCP, so you can add like Expedia to your ChatGPT, and it will be able to access it for you. So here, what we're going to do is, next step is throw away what we did with the tool that we wrote together, replace it with MCP. To do so, every MCP has its own specific way of, hey, you can run it this way, you need these libraries. So basically I went, I looked at the documentation and learned how to run this specific MCP and put the code down for you guys. So all you have to do is, again, follow me, right? Run this cell that would install that MCP server time. Next, we're doing a studio for basically the way we want to access MCP. How many does we have left? 4?
Mm-hmm.
Okay, well, I'm going to keep one for, I'm going to keep 3 for the challenge if you get to it. But I'm going to ask one question here. So MCP, basically, so what happens here with MCP is you're specifying that I want to run this MCP server. Where is it actually running? Does anybody know where the server is running?
Locally?
Exactly. So you get it. That's tricky for some people. They always think that the server should run somewhere else. But all we're doing here is actually we're saying, hey, that I want you to start a sub-process, run this MCP server for me locally, and basically get access to it. This is not the only way. Actually, if you go say sign up for one of those web browser MCPs, most of them actually are not running locally. But then they will ask you to use HTTP rather than MCP. Okay. Next, so all we did right now is just set a new variable for our MCP server, the time server. We're going to run the next cell, which is all it's going to do is replace, remember you had tools and then we call it, I forgot what we call it, but now we're going to replace it with this time server that we just defined. So if you run this cell and run what's the date today, you'll get the same response, but now instead of that function that we defined, we use an MCP server. Are we all good? We're following? Any issues with the notebooks? No? Good. Okay. This is the last part of this, so I think we're doing fine for the challenge. I'm going to leave like 10 to 15 minutes. And I know there's a challenge at the bottom there. Ignore that. I have 2 challenges, so you could use one of them. And the first 3 people who finish them can get one of those water bottles that are left. So this is the last part of this workshop. And as of now, you actually have an agent that you just built right now. So first, if you said at the beginning that you never use AMD GPU to build AI, now you have. So second, you get to try something on your own in a few minutes. You can maybe expand this agent or write your own tool. Next part is we want to do something a bit more useful and actually show how the agent can actually have access to multiple tools and reason and think how to use those tools together. So again, this is a Airbnb MCP that I found online. Somebody just wrote it, and it's basically calling the web browser and getting the results for you. It's nothing fancy, but the person who did a great job. Packed a few tools, and you can get access to it. It's just basically the way I have it here. You do need more dependencies for this one, so you need Node. That's why I install a Node. And using npx to run it. That's a command when you want to run this server. So that's the next part. So finally, here is the updated agent. So you can see here now have two tools added here. One is a time server MCP, and one is the Airbnb server MCP. I have obviously updated the system prompt, but if you run this, now your agent should be ready. So a little bit of explanation before I run this last prompt here. So I'm asking this agent right now to find a place for you to stay in Vancouver next Sunday for 3 nights. So if you think about this prompt, it's not telling the date, right? It's saying next Sunday. And the reason I'm doing that is I want to show you guys that the agent actually is smart enough to figure out that I need to calculate what next Sunday is. It doesn't know the date, so it needs to call that date. And then it calculates what the next Sunday is, and then the correct dates, push it back to the MCP server for Airbnb and get the results. And I'm running it for Vancouver because it's the city I grew up in, so we'll see if it can find some good spots for us to stay next Sunday. So this will take a few seconds since it has to do the whole API call, but there you go. You should have some URLs. Let's try one of them. Make sure they're not hallucinated. There you go. So it's a real Airbnb, and it's in downtown Vancouver. So now you just built an agent that can actually find a suitable spot for you to stay. If you visit wherever you want, so you can change it from any Vancouver to any city. All right, I think we're doing great for time. I kind of want to have about 12 minutes from now for the challenge part, and then we're going to wrap up the last 5 minutes with some final slides, and we'll be done for the day. So basically for challenge, you can actually go, so once I want to code, if you've never done that again, there's a plus button here, can create a cell code for you, so you can go write your code. But we have two potential challenges for you that you can pick. You don't have to do both, you just do one of them. So one is using MCP, one is using your custom tool, right? You can create a custom tool to get GPU VRAM usage. I'll show an example of that in a second. Basically, the same way we did the custom tool we created, I want to see if you guys use AMD SMI API, so you can Google AMD SMI API, Python API, and see if you can quickly write a function that you can turn out to a tool that you can ask the agent how much of VRAM am I using right now. So the GPU VRAM utilization is what I want to see if you guys can get. Or you could just use challenge 2. So you can look up MCPs that give you current weather and add that to your Airbnb agent and see if it could actually give you the current weather for, say, Lisbon. So I'm gonna give you guys the 12 minutes starting now. If you finish it, please come forward because I've had the situation that people are fighting to put my hands up first. So I want to avoid that. So if you finish it, please come forward and then we'll evaluate your code, and if it's correct, you'll get one of the water bottles. So the next 10 minutes or so is yours.
Are only to be used in-house there's no point in using an MCP server. Yes or no? What's your take?
Okay, let me repeat the question to make sure I understand it
Okay,
correctly.
you build tools for like get. If the tools you are providing to your agents are built in-house for your own use, is there any gain you have by building an MCP server instead of calling directly the tool?
It's a good question. So the question is, if I make my own custom tools, say for my own company or use case, is there a point to make that into an MCP server, or should I just leave it as a custom tool and just use it that way? The benefit of you moving that to MCP is there's a few. One is if you have like 10 functions that are you can categorize them within the same sort of stuff. Say you wrote tools to get GPU stats, one of the GPU failure cases or whatever. So there's like same category. If you don't use MCP, you need to go add every tool one by one to your agents. If you use MCP, all you have to do is expose the MCP server, and that MCP server packs all of them as one, right? That's one benefit. Second benefit could be, say you're using multiple agents, right? So you're using one agenting framework from PydanticAI, one from LangGraph. Every single agentic framework has its own way of defining tools. With MCP, they're all the same. So you don't have to worry about, porting your tools from one framework to another framework. So those are two I can think of on top of my head.
It
Yeah.
makes sense to me.
Yeah.
Does the data from the MCP server prevails the data that it was studied on? Like, for example, if it was studied that the Biden was the president for a long time, like 4 years, and he gets a call from the MCP, from the internet, and gets, like, it's not Trump, so it must be prevalent, yeah?
I'm having a little bit of difficulty to understand, but I'll repeat what I assumed that he said. Are you asking about the data flow between MCP, whether it's exposed to, is that what you're asking, or?
Does the data from the MCP prevails what the model has learned while training?
I think he's asking if the what is returned from the server, the MCP server, overrides the assumptions the LLM may have.
Yeah. If your question is whether what's returned by MCP server is going to overwrite,
Yeah.
no. Okay. So on the back end, how it works is the LLM figures out that it needs to call a tool, right? It creates that little for the agentic framework. It says that the response is, I think I need to call a tool, and then this is the tool call. Then it's the framework that calls an MCP, right? It's not the LLM directly. The framework calls the MCP, gets the result back, passes it back to the LLM, and says, this is what I got from the MCP. And then the LLM goes and is like, okay, that looks good to me, or we need to call it again, or do whatever with it. Then LLM will use that data to generate a new response for you. So it goes through this back and forth. I can't hear, maybe. Oh, great. Do you mind bringing your laptop here? So we have the first person claiming the first prize. So for me, I think that would be it in terms of A and D presentation. I think, Kyle, you have a few slides to wrap up, or is that it?
Yeah.
Okay.
Yeah, so if anyone does need compute for their company or